Did you know that the residual glow of the Big Bang can be seen on TV at any time? Turn on an old analog TV between channels. There, in front of you, will be a screen full of black and white specks, about 1% of which are caused by photons that have remained since the inception of all things. This is the cosmic microwave background, or CMB, radiation noise uniformly filling the universe. So, is it possible to see the Big Bang itself, the mystery of our origin, which remains relevant to this day? What if you replicate it in a laboratory? It's incredible that scientists' attempt of such a recreation was a success in this year. Today, you will learn about the most unusual explanation for what caused the Big Bang. Perhaps the first thing you should understand about the Big Bang is that it was not an explosion in the usual sense, and did not occur inside of anything. Let's go back to the very beginning of time, as if we were rewinding an incredibly long film about the history of the universe to the very first frames. If we were to view the entire film in reverse, in just a day, the history of mankind would have fit in about 0.4 seconds and ended long before the opening credits disappeared from the screen. The first animals would appear about an hour after you comfortably settled down with popcorn. For more than 7 hours, you would wait for scenes of the formation of the Earth and the solar system. And then, for another 16 hours, you would suffer in anticipation, waiting for the incredible, phenomenal power of the explosion. However, we would never see this explosion, since the name Big Bang, which was given to this phenomenon as a joke by an ardent opponent of the theory of Sir Fred Hoyle from the University of Cambridge, hides the reality that it was an expansion. An explosion is a shock wave caused by a sharp separation of high-pressure gas and low-pressure gas. The universe, in the early stage of the Big Bang, was compressed, with all its mass and energy concentrated into one super-dense point, smaller than an atom, and even subatomic particles, and it was also heated to 1,000 nonillion Kelvin, or about 180 nonillion degrees Fahrenheit, which the Belgian astronomer Georges Lemaitre called the cosmic egg. Considering time, it was necessary for the universe to grow from this point to its current size with a certain expansion rate, while taking into account its temperature. Scientists came to the conclusion that it was about 13.8 billion years old. Sure enough, the Big Bang Theory is more than a description of how a tiny object became so enormous. As this ball of pure, colossal energy expanded and cooled, various states of matter, energy, and even forces of nature appeared. All this is similar to the transformation of cooling steam into water and then into ice. So it's assumed that at the very first moment of the Big Bang, the universe contained only one form of energy, and then it became unstable, and in the next 10 to 35 seconds, its volume expanded by about 1,070 orders of magnitude at a speed many times greater than the speed of light. This short period of rapid expansion is called cosmic inflation, although the universe, at the same time, grew to just a few cubic meters in volume. This turned out to be enough for the primordial matter to form from the released energy in the form of a soup of subatomic particles, quarks. After about 100,000 years, light was able to separate from matter, plunging the universe into 300 million years of darkness. And after 380,000 years, atoms formed, and a large amount of energy was released, the remnants of which are now cosmic microwave background radiation. The appearance of the first stars marked the end of the dark ages of space, and their integration into gravitationally bound systems laid the foundation for galaxies, one of which is our very own Milky Way. So, with the exception of some gaps, we know pretty well what happened during and after the Big Bang. But what if you try to rewind the film even further to find out what destabilized the original ball of energy? What existed before it? And did anything really exist at all? Trying to answer these questions, scientists stumbled onto the so-called singularity. This is the primary state of the universe. The fact is that time and space only began to exist after the Big Bang. But before that, neither of them, nor cause and effect, nor the before moment itself, were present. But cosmologists are trying in every way to circumvent the singularity. As a result, some take it for granted that the universe simply appeared out of nothing as a result of random fluctuations. That is, particles spontaneously arose from a vacuum. However, opponents of this theory believe that the universe existed before the Big Bang, though little can be said about this foremother. Perhaps it was like our universe, or perhaps it was something completely different. We can only assume that something happened in her story that gave rise to the Big Bang. There is another opinion that before our universe, there was a collision between two brains of two universes. Their collision led to the Big Bang. Why stop at just two universes, argue proponents of the metaverse or multiverse. They believe that at the time of its formation, the newborn universe swelled to enormous size, giving rise to bubbles from which different universes grew. If this is true, then our world is only one of billions, just like our Milky Way is one of billions of other galaxies. A number of researchers also argue that the universe exists forever, and the Big Bangs in its history are counteracted by big compressions in which the universe collapses into a singularity. The calculations of famous physicists Stephen Hawking and Roger Penrose show that the Big Bang cannot be fully understood by classical cosmology, like Einstein's theory of relativity. With a singularity, only the laws of quantum mechanics apply, according to which diffuse wave particles move in all possible ways. That is, the universe can have an infinite number of prehistories, since without an outside observer, matter is in limbo. Based on this, it all starts from the point at which the temperature, energy density, and curvature of spacetime were very large. From there, the universe began to expand according to the inflationary model and continues to do so to this day. But in 2019, Karim Ahmed, assistant professor of the Department of Mechanics and Aerospace Engineering at the University of Central Florida, announced a completely new version, drawing an analogy between the birth of our universe and a supernova explosion. The difference is only in the vastly different scale of these events. Type 1A supernova explosions occur when carbon and oxygen compress to a density of about 16,667 tons per cubic inch, or about 1,000 tons per cubic centimeter, in a star's core, burn up in fast thermonuclear reactions. The explosion destroys the star in a matter of seconds and ejects most of its mass, while emitting the same amount of energy that a star emits throughout its entire life. Of the former star, only a shell remains, which is a mixture of various gases and substances. As a rule, for detonation, combustion should take place in a space with walls or obstacles, but stars have neither, and this used to turn their detonation into a kind of riddle. A team of scientists, one of whose leaders was Karim, has developed a theory that sheds light on this mysterious process. According to them, a passive flame caused by turbulence can accelerate and ultimately explode on its own. Researchers have successfully reproduced a similar event in the laboratory with the help of the largest supercomputers. They created turbulence in a 2-inch shock tube so that the passive flame became active. At the end of the experiment, a powerful explosion occurred, which might be similar to the Big Bang, only in miniature. True, there's no way to confirm this claim that this is indeed a miniature copy of the Big Bang, since we cannot go back in time to find the exact conditions that initially caused the reaction. The results obtained should not only help us to better understand the age of the universe, but will also come in handy in the operation of hypersonic engines and in the modernized production of electricity. So, what do you think might have been the cause of the Big Bang? Please tell us in the comments. If you liked the video, give it a thumbs up, subscribe to the channel, click on the bell to enable notifications of new videos, and don't forget to recommend us to your friends.